I want to talk to you today about space, and in particular about this place that space occupies in the human imagination. So space kind of has this peculiar spot, right? We use it as this abstract concept, and we use it as metaphors for just about everything, and occasionally we just use it as a fictional backdrop for whatever it is that we're worried about, our future of ourselves as individuals, of humankind, of our own planet. But ironically, space is not an abstract concept. It's actually location. By its very definition, space is a location in place and time. And so, to me, space is really not abstract, not at all. And, you know, I really think that it's because I have the benefit of working on these objects and systems in astronomy that are really true locations, locations as we experience them in our everyday lives. Now, the reason for that is that I work on a mission called Kepler, and Kepler is a NASA mission. It's a space telescope, shown there, that was launched to look specifically for planets orbiting other stars, or as we call them, exoplanets for short. Now, what Kepler does is it stares at this one part of the sky, and the part of the sky that it looks at is about as big as your palm, out at arm's length. And it looks at this part of the sky, and it measures the light from around 160,000 stars in that little patch of sky. And it makes these very precise measurements of how bright they are with time, which you can kind of get an idea for if you look down at the lower right there. Now, what it's looking for is for planets to pass in front of their star and block just a tiny little bit of the light. So every 30 minutes, we measure how bright these 160,000 stars are, and we wait to see if there's one that every so often becomes slightly dimmer. Now, Kepler's not just looking for planets in general, although it does a really good job of looking for planets in general. It's really looking for planets that are small, planets that are the size of Earth, which, comparatively speaking, with the other kinds of planets that we know out there, is a pretty small planet. Now, because Earth is small, it means that when it passes in front of its star, or a planet that's the size of Earth passes in front of its star, it doesn't really block very much of the light. And so the measurements that we make have to be really, really, really precise. And so to give you some idea of, basically what your job would be if you were Kepler, so this is a little bit like if somebody was shining their car headlights at you across a football field, and your job was saying whether a fly had passed in front of one of those headlights. So pretty hard. Now, before Kepler launched, there was no other instrument that could do this. And so it's really just been in the past couple of years that we've been able to find planets that are the size of Earth. Now, Kepler doesn't just look for planets in general. What it's actually looking for are planets that are in this particular region around their star. And we call this region the habitable zone. And we call it that because it's right about the right distance from the star, where the planet gets enough light that we think it would be about the right temperature to have liquid water on the surface, perhaps. And if it has liquid water, then by extension, what we're really trying to see is whether it would be hospitable for life. And so you can think of it a little bit like if you were sitting around a campfire, you want to be just the right distance away so you get enough light from that fire to be warm, but not so far away that you're cold and not so close that you're really baking hot. So conveniently, here's where the habitable zone lies in our solar system. We are sitting in it, which is why we are having Creative Mornings this morning. And so we're really looking for planets that are the size of Earth in the orbits of stars in the habitable zone. Now, Kepler launched about 4 years ago, and it's really been, in those 4 years, a lean, mean planet-finding machine. So it found in just this one little patch of sky around 3,000 potential new planets thus far in 4 years. And while that's, a lot of planets to begin with, if you think about this little palm against the sky, that's actually a relatively small part of the rest of the sky, right? And so what Kepler's really doing is counting up just the planets that are in that patch of sky. We look, we monitor the stars, we see which stars have planets, we see how big those planets are. We can tell whether they're in this zone where they might be the right temperature for liquid water. But by extension, because that part of the sky is not special in any way, we can tell then how many planets, percentage-wise, should be in our galaxy as a whole. So Kepler doesn't find every planet that's out there, but what it does tell us is that planets are really, really common, and particularly that small planets, the size of Earth or so, are really, really common. And so what this means is that when you go outside and you look up at the sky, it's not just that the sky is full of stars, it's that the sky is really full of other worlds. So I want to take a step back for a moment because, to astronomers, all of this stuff is just sort of interesting just for the sake of doing it. But, exoplanets really kind of hold this particular place in the imagination, not only of scientists, but of the public as a whole. And you can see that in the press coverage that gets given to exoplanet discoveries. So what is it really about these alien worlds that we find so captivating? Well, if you think about it, what we're doing when we use Kepler to look for planets is we're looking for the real estate that might exist in the universe where life could be found. So we're really looking for where there might be life. And when we make a decision to look for a planet that is roughly the size of Earth around a star that's kind of like our sun at about the same distance, so it's the same temperature, what we're really looking for is the real estate that would support life that's kind of like life on Earth. Now, part of the reason for this is practical. At the moment, we can't go to any of these worlds. And we can't even take detailed pictures like we can of our own planet or the other planets in our solar system. And so often when you hear about exoplanet discoveries, the thing that we're observing, that we're actually measuring, is the star, because the planets are so hard to see that usually we just detect them based on their indirect effect on the star itself. And so, in part, if we want to be able to recognize life at these astronomical distances, we need life to modify its planet on a global scale in kind of a similar way to the way that life here on Earth modifies our planet. And that's because we really only have one example of a planet that has life on it, and that's planet Earth. But beyond just the practical considerations of actually recognizing life from all the way across space, there's also a very fundamental part of this research that I think touches on human questions, not just scientific questions. And that's, who are we? Who are we not just as individuals, but who are we as a species? Who are we as a planet? And so these planets that we're finding are not abstract concepts. They're not abstract locations or fictional backdrops. They're real places. And even though we can't go there, at least in my experience, I feel connected to these other planets through my work and through science. And so one of the things that I spend a lot of time thinking about is how to give people that same personal connection to space. Because to me, when I say that space isn't abstract, I really mean it. To me, space is personal. And to all of us, space is our home. Now, one of the things that I really like about being a scientist is that, to me, I sort of feel like I have this automatic augmented reality experience of the world around me. So at any given moment, there is at least another layer, usually several, of information in the world that I feel like my training as a scientist allows me to access. And that's part of one of the things that I really like about being a scientist. And because I get really excited about my work, and because I think that we're starting to impact these sort of fundamental human questions, in addition to ones that are just interesting for science, I feel really compelled to share this with other people. And in particular, like I said, I'm compelled to give people that personal experience so that it matters to you the way that it matters to me. And it really bothers me that, in popular culture, you kind of get this idea that scientists are, almost like a separate subspecies of Earthlings. that were kind of laboring off in these hermetically sealed ivory towers, and that were like a little bit crazy. So the example that I'm showing you here on the right is from this great project where these 7th graders went to Fermilab, which is a big particle physics lab. And they drew pictures and wrote descriptions of what scientists were like before and after they met one, which led to the astounding conclusion that scientists are actually normal people. The paragraph on the right kind of goes on to rapturously describe the scientist's love of racquetball. So I highly suggest you check it out. It's really kind of a cool project. And it's not that there aren't reclusive scientists or scientists who are eccentric, but, there are also reclusive postal workers and reclusive bakers and reclusive writers. But it's part of the mythos of science and scientists that we don't really relate to the world around us, even as we try to understand it. But, of course, this is ridiculous, because if you think about it, science, and by extension technology, is almost fundamentally and uniquely human. And so it doesn't matter whether you think science is awesome or whether you think science totally sucks, because science is, at the very least, a very, very human undertaking. And so if space is personal to me, then it can be to you as well, if that's what you want. Now, I think part of the issue that was kind of touched on by that drawing of a scientist before and after is that people often don't know a scientist. They don't really have personal encounters with scientists. And if you think about it, it's actually extremely uncommon that you have a conscious, unplanned encounter with science in the course of your life. Whereas we can go out to parks and have encounters with art via public art spaces, and we can see monuments and have an encounter with history, or you can see an inscription and have an encounter with literature that you wouldn't have had otherwise. It's very rare that you have an encounter with science. And so we have this problem where if people are already interested in science, they'll read the science section of the New York Times, or they'll watch science programming on TV, or they'll go to a science museum. But what about the rest of the world? So a couple weeks ago, some friends of mine and I did a little experiment that we called Science Train. And this was just a couple Saturdays, I guess 2 weeks or so. What we did was we made a sign, and we went on the C train, and we rode the C train from one end to the other and then some, and we just sat around and talked to people about, well, what else? Space. And so this was really it was a really fun day. You wouldn't think that riding the C train all day would be really fun, but it was. And it was also, for me, really illuminating. So in my quest to give people a personal connection to science, I thought this would be really wonderful. And I thought that, I would be sharing with them my work and all this stuff. But the thing that I didn't expect was that almost everybody we talked to told us about their personal connection to science. Unfortunately, what they told us was usually in the context of the moment that they decided that science wasn't for them. And so what I realized is that actually a lot of people already do have a pre-existing personal connection to science. It's not something that I have to give them or ignite in them. It's that somewhere along the way, they were interested, and they got this message that if they didn't want to do it professionally, that it just wasn't for them at all. And I think that's really a problem. And I think it's a problem because what science, and particularly the study of space and study of astronomy, gives you is a real sense of perspective. And I think that if we're going to be able to solve some of these really wicked challenges that are out there for our future, we need to be able to think globally. And so I think that science can really help with that, and in particular, understanding that we really are just the only inhabited planet that we know of in a world, a universe that's filled with planets, other planets. It makes you feel small, but it also makes you feel connected to the rest of humankind and the rest of life on Earth in general. So fortunately, although that message is still out there that, if you're not a professional scientist, that you can't do science, I think we have the power to actually change that message now. And it's not just because technology makes it possible for information to be more readily accessible. I mean, being able to access information is really great and all, but it's not really something that people necessarily connect with. And perhaps more importantly, just being able to access, news about scientific discoveries or scientific facts, it really has actually pretty little to do with science itself, because science is a process, not a result. Science is a way of understanding the world around you. And so I think what's powerful and that's happening now that technology enables is the ability of people who are not from formal science backgrounds to participate in scientific research, and that's through something called citizen science projects. So, for example, there is a project called Planet Hunters, which uses the Kepler data and teaches you to look for planets in the measurements that Kepler makes. And so all of the interaction is in the browser, so you don't need to download any kind of specialized software. And there's a little tutorial at the very beginning that, in about 10 minutes or so, teaches you what to look for and enables you to start flipping through the data and actually looking for planets. And of course, I'm partial to Kepler's citizen science project for obvious reasons, because I like planets and looking for them. But this is actually just one of a much larger family of citizen science projects that are out there, many of which are hosted on this website called Zooniverse. So although the examples at the bottom there are space, the Zooniverse family of citizen science projects actually encompasses a very wide range of things that you might be interested in doing. So for example, not only can you look for planets, but you can also look through images of motion cameras on the Serengeti and look at animals. You can look at images of the seafloor. You can read historical ship logs to help track weather. And of course, you can also do things like look for galaxies in deep space. And I think this is really cool because the discoveries that are coming out of these citizen science projects are things that would not have been discovered otherwise. So in the case of Planet Hunters, you have citizen scientists and professional scientists collaborating together to actually discover exoplanets, planets around other stars, that would have been missed otherwise. And amazingly, they're also collaborating together to start writing papers together, to write academic papers that end up in the scientific literature, which traditionally has been, the hallowed ground of people with a whole lot of formal training in science. And I want to emphasize to you that, the 850,000 people that use the Zooniverse website are not all out-of-work scientists. They're actually people from a really wide array of backgrounds and a huge range of ages, from the very old to the very young. And they cite as their number one motivation that they just want to be part of scientific research. And they are, because they're making these discoveries that we would have missed if it weren't for them. Now, perhaps more importantly than just interacting with the data and learning to make these very specific measurements and helping answer a specific question about that data, the citizen scientists that use Zooniverse are also doing something that professional scientists do a lot of, and that's communicating with each other about what they've found. So again with the myths about scientists, there's kind of this image that we're all lone geniuses, like working in our garage and not talking to anybody. But actually, communication between scientists is the lifeblood of our work. It's how we understand our data. It's how we figure out what it is that we're really learning. It's how we learn to interpret things. And it's also where we get ideas about what it is that we'd like to look at next and what the new, most interesting problem is. And so through the talk section or the discussion forums that are on the Zooniverse website, the citizen scientists and also professional scientists who occupy the forums are sitting around and talking not only about the very specific measurements that they're making in their data, but they're talking about other things that they weren't specifically told to look for as well. And so they're having a real dialogue about some of the things that are in the data that maybe wouldn't have, again, gone discovered if it weren't for them. And so this has happened again and again. And we found that just naturally, the users of Zooniverse will dig deeper into the data and go looking for things that they weren't told to look for to begin with, just because they're interested. Now, some advanced users have actually gone a step or even 5 before beyond the Zooniverse environment to learn how to use professional tools and professional websites to gain additional information about whatever it is that they've happened to have seen in their data and try to understand it themselves. Unfortunately, you really have to be extremely motivated to do that. And that's because the cliff of usability that you fall off when you leave the Zooniverse environment and go into the rest of what's out there is really, really very steep. And the reason for that is that, scientists, we kind of take bad user interfaces and temperamental software behavior for granted because our tools are very specialized. And as a result, we tend to just put up with it because usually our tools have been designed by either ourselves or maybe one of our colleagues. And we don't typically have backgrounds in things like human-computer interaction or even software development. And so we're really kind of willing to put up with a lot. And so in some sense, one of the things that keeps science separated from people is not just that we have to go through all this schooling and take all this formal training, it's that the tools of the trade are really arcane and clunky. And they serve to make it obscure for everybody else who isn't just calloused enough to go on using them. And so as a result, you have all of this amazing astronomical data out there that's all public. It's just all public sitting out there for the most part. But the fact that the data is available is not enough to empower people to actually go about using it because of the clunkiness of the tools. And so I think that the triumph of citizen science projects and their real success is a testament to the way in which good design and the right set of tools can really empower people. Because of the Zooniverse environment where you get to actually interact not only with the data, but with other citizen scientists, you get to have this conversation, and you have this right set of tools, this is allowing people to actually ask questions about the world around them. And I think that's really exciting. So at the moment, most of this has been at a very basic level where you come in and you take a tutorial and it teaches you to make a very specific kind of measurement or interaction with the data. But I think what's exciting now that's happening is that we're trying to enable people to dig deeper into the data in the way that some of those advanced users have been able to do. And what I think is powerful about that is that you can allow people with this suite of tools to actually start asking their own questions, to figure out what it is that they find interesting, what is it that they want to know about the world, not just what somebody else has told them is an interesting thing to study. So this building here, which looks like a totally awesome Bond villain hangout, is actually the Adler Planetarium in Chicago. In addition to being the first planetarium ever in America, it is also home to a lot of the development of the Zooniverse suite of projects. And it's also my future home because in a year, I will be moving to Chicago and I will be joining the Adler's astronomy department. Now, a couple weeks ago, what we did was got together, so the Zooniverse developers team gathered at Adler, brought in a couple of scientists, and what we did was we sat around and we tried to figure out how to make a suite of tools that will make it possible for people to dig into their data more easily without having to fall off that usability cliff. And so these are in their very early stages. They're called the Zoo tools. And what we did was just over 3 days or so kind of put together a couple of neat things. And so the environment is very similar to sort of a dashboard environment. Again, everything is in the browser, so you don't need any kind of specialized software to be able to do this. And what it allows you to do, here's a very simple example, is to, rather than just interact with the data in this very prescribed way, you can actually load it into the dashboard. You can, for example, if it's an image, stretch it different ways, manipulate the image, see if you can bring out some structures over others, because a lot of times what we're doing in astronomy is trying to identify things that are very faint or difficult to see in images. Another thing that we do a lot is that sometimes you want to make measurements on those images, or you want to make graphs of how one property relates to another of some astronomical object. And so you'll also be able to do that in this environment, where you can actually start getting derived quantities rather than what's just served up to you at the basic level of interaction with these projects. And so this is really to make it possible for people to dig into the data and to start asking questions. And as I mentioned before, the other part of science that's really important is to be able to share this with people. And so one of the things you can do is also save the state of your dashboard. So you do some analysis, you save it, and then you can actually export it right to the discussion forums. And that'll allow you to share with other people what it is that you're seeing and actually talk about that stuff in the same way that you would if you were a professional scientist, just much, much more easily. And so I really think that what we're experiencing now is that the power of technology allows us to make these questions, to formulate these questions and then investigate them with the data that's really out there. And so I think that this is something that for most people, if they're interested, if they want space to be kind of a personal thing for them, that can be possible now because we're kind of starting to democratize science and to make it more open, to make it more accessible to people. And most importantly, to get rid of that message that if you don't want to be a professional scientist and do it all day, that it just isn't for you at all, and that your role can only be that of the consumer, because it doesn't have to be. It can be something that's more active than that. And so as I start to wrap up, what I'd like to leave you with is something of a bittersweet note. So earlier this year, Kepler, this wonderful mission that has been able to give us these thousands and thousands of planets that we didn't know before, that has taught us that planets, at least the size of Earth, are extremely common in the universe, and so there might be lots of real estate to go looking for life. Well, Kepler had a failure. Kepler broke. Kepler had a failure in one of the critical parts that allows us to point the telescope, to stare at that patch of the sky, and make these measurements that are so precise that allow us to detect the effect of planets in blocking some of the star. And I have to tell you that when the news came to us, I actually started crying. I mean, it's a little silly, like Kepler's an inanimate object. I'm pretty sure the last inanimate object I cried over was like an ice cream I dropped when I was like 4. But nonetheless, like I kind of felt really attached to this, hunk of metal in space. In that, I really felt like a friend had been in an accident. And over this next couple of weeks, you may even hear about Kepler because right now we're trying to figure out if we're going to be able to revive that moving part, whether we'll actually be able to return Kepler to operating and doing its exoplanet hunting mission. But it doesn't seem very likely at the moment. So on the one hand, that's sad. And Kepler will be missed. But on the other hand, the fact is that there's so many amazing other missions that are just coming up on the horizon now. Missions that'll tell us not just the percentage-wise number of planets that we can expect in the galaxy, but missions that will be able to find those planets, that will be able to characterize those planets, to tell us whether life is maybe modifying the planet on a global scale and allow us to detect life on other worlds in other solar systems in the universe. And so it's really hard for me to stay sad for long because, I see coming down the pike all of these other missions that'll be producing new data on new worlds. And I think right now what we'll really need is new eyes on that data, because otherwise, as we've demonstrated, there are discoveries that will go unmade if we don't have that help. And so it's a really big sky and it's a really big universe, and I would love it if you would come and help us explore it. But I thought that before I'd go, I would give you an example of what it sounds like to be really, really excited about science. Because maybe you don't know. So I just want to play you, this is a little bit of raw footage from the Kepler launch. So it's taken from kind of far away in this spot called Jetty Park, where you can watch the shuttle launches from Kennedy Space Flight Center. And the visuals are not great. The glowing thing is the rocket. But I think that the sound is pretty awesome. And I will tell you that this is, in fact, a NASA employee, somebody who worked on the mission. It is not me, but it is someone who I think is undeniably really, really personally invested in space.
15 seconds.
Oh my gosh.
9, 10, 9, 8, 7, 6.
Oh my god. Oh my god. I can't believe it. That's surreal. Oh my god.
Thanks.